So here we have your first homework assignment. It's a prerequisite assignment. It's about lines. It's literally just graphing lines and working with the various forms. I'm not going to do all of them. Some of the stuff you need to do. Let's look at the first one, which is x equals a constant. It's a straight vertical line. So we're just going to pick some place. We're going to draw a vertical line. When you guys take your mother function quizzes, I require you to label that point where you cross the x-axis as C0. All right, let's talk about this thing's domain and range. This thing has a domain of whatever this constant is. Like right now I'm crossing 3. I'm just going to say the domain is C, this constant, whatever x is. That's what it is. Its range, it falls forever and it rises forever. If we use interval notation, we would say that's negative infinity to infinity. If we like set builder notation, we would say all values of y such that y is an element of the real. And I kind of forgot about set builder notation up here for domain. It would be all values of x such that x equals a constant. All right, moving on to number 3. 3 is the mother function of all lines because all lines by and large look like number 3. It's y equals x. If you're a table kid, which I make you do, have x and y, whatever x is, y is. And these are the 3 points that we use quite often when we do graphs. We use -1, 0, and 1 as the x values. So we're going to contain -1, -1, 0, 0, and 1, 1. 3 nice points will give us that nice looking line. Remember, lines go on forever left and right. And speaking of that, domain the values of x that you see x values that run forever left to negative infinity and forever right to positive infinity. Or if you're a set builder kid, you would say all values of x such that x is an element of the real. The range, in addition to running left and right forever, is also falling and rising forever. So the range is also negative infinity to infinity. The domain and range of any slanted line is always negative infinity to infinity. If you like set builder, all values of y such that y is an element of the real. A lot of standardized tests have gone away from this YER and XER notation, and they would literally write it like this. They'd say bracket y bar, that would still be there, and they would say y is any real number. They try and dumb it down a little bit. That's pretty common on a standardized typed test, but if you're writing, use the XER and YER notation because it's shorthand. All right, let's graph. I just don't want to do too many of them. Let's take a look at 5. 5 is in what I call vertex form of a line. So it's in the form a times x minus h plus k. Our slope here is the a value of -2. Sorry, it got off there on the board there. And the y-intercept is at 0, 5. We're just going to write 5. So we're going to count up 5, put a nice dot, and from there we're going to fall 2 and run 1 for all of eternity. The more dots you put, the straighter your line's going to be. And there's your line. And this is a slanted line. The domain and range of every slanted line that will ever exist is negative infinity to positive infinity. And I don't care if you write set builder notation if you want to. All values of y such that y is an element of the real. Or up here for x, all values of x such that x is an element of the real. All right, moving forward. We're supposed to do some converting here. Let's look at number 8. 8, you're given something in vertex form. So that means you don't have to do this part. But just convert that into slope-intercept form, which is y equals mx plus b. That's literally as easy as doing something we call the distributive property and then combining like terms. So we're going to distribute that -2 into x minus 3. And the first thing we're going to have written is going to be -2x, because -2 times x is -2x, plus 6, because -2 times -3 is positive 6, and then plus 7. And following through with our kind of order operations here. Remember, we just did multiplication, which is before adding and subtracting. 6 and 7 makes 13, and there is the function in slope-intercept form. Let's look at number 9. You are supposed to convert -5x plus 8y equals 12 into 2 different forms, slope-intercept form being the first one. And there will be fractions. That's not a big deal. But slope-intercept form is y equals mx plus b. So we're going to get the y's by themselves by isolating the 8y. If you jump equality, change your sign. The 5x was negative, now it's positive. And the last thing to do to make it look like y equals mx plus b is to divide out that 8, because we want y equals, not 8y. So we divide everything by 8, and we don't worry too much about the fractions. 5/8 will not simplify, that's as simple as it gets. 12 over 8, those are both divisible by 4, right? That becomes 3 over 2. And there is that thing in slope-intercept form. Now, the vertex form is going to be a little bit harder to do. To do vertex form, notice how you got this a out in front of a set of parentheses? Well, your first step here would be to move that 5/8 out in front of a set of parentheses and then put an x value there. You can arbitrarily make up a number, like I'm going to just say plus 2. And I'm going to go off the side, I'm going to think about what is 5/8 plus 2. Or sorry, 5/8 times 2. That's 10/8, which is 5/4, because 5 times 2 is 10. I had plus 3/2. What I've kind of done here is I've kind of added 5/4 to the equation. But the original equation said plus 3/2. So now I've got to figure out, okay, how do I correct this and not change the numerical value of the intercept? I got to think, what do I take away from 5/4 to make it 3/2? 5/4 take away what is 3/2? Well, that can be done by doing 5/4 minus 3/2. And that'll give you that thing you're after. I know this is kind of hard for some kids to deal with because, one, they're fractions and not numbers we can think of easily. In order to add or subtract two fractions, you have to have the same denominator. So we're going to change that 3/2 into 6/4, and then I can do the math here. 5 minus 6 is -1. So now on the outside, I'm going to say -1/4, and that makes it numerically equivalent to the original equation given. There's a reason I did number 9. It was the rough one. Let's see here. Next thing I'm going to do is number 11. State the domain and range of the graph below, then write the equation for the graph in slope-intercept form, standard form, and vertex form. So the domain, like that's a line, goes left and right forever. Negative infinity to positive infinity. It falls forever. It rises forever. Negative infinity to positive infinity. Slope-intercept form. Wouldn't be hard to do if I had labeled this order pair correctly. I need to fix that in the worksheet here. It's actually 0, 1, not 1, 0. So we have a y-intercept at 1, and let's think about y equals mx plus b. The b value is 1, and now we need our slope. We're going from -6, 0 to 0, 1. So we are rising 1 and running 6. We rose 1 and we ran 6. So our slope is 1/6. And then we're just going to feed y equals mx plus b. It's 1/6 of x plus 1. Easy peasy. Moving forward to standard form. Standard form is ax plus by equals c, where a is a positive integer. BRB. All right, so where was I? So where a is a positive integer. All right, so you'll notice that the x's and the y's are on the left. So the first thing I'm going to do here is I'm going to shift this over. And you'll notice the x's are in front of the y. That's going to make it -1/6 of x plus that y that's already there equal to 1. This is supposed to be a positive integer. So the opposite of being negative is positive. We can multiply everything through by a negative, and that would make it a positive integer like it needs to be. The opposite of dividing by 6 is multiplying by 6. So what we're going to do is we're just going to multiply every single thing by a -6, and that's going to clean it up and make it look like it should. Algebra is really just about knowing the opposites of things. Now, -6 times -1/6, the 6 and the 1/6 cancel, you just get a positive x. A -6 times a positive y is -6y. And a -6 times a 1 is -6. And there she is in what's called standard form. All right, up next is vertex form. And vertex form is the one I think it's tricky. I don't think you guys were taught to think the same way my generation was. We were just learned how to manipulate numbers. And that's what it's about, manipulating. First things first, we're going to pull that 1/6 out, set of parentheses, and we're not even going to carry down this +1. Think about it, there's a +1 there. I'm going to do something simple like say -1. What that would do is that would give me an equation of a line that is 1/6 of x minus a sixth. However, the original one was 1/6 of x plus 1. I fixed this by simply saying plus 7/6 outside, because -1/6 plus 7/6 is 6/6, which I know I'm speaking a foreign language to you right now, but 6/6 is 1. That's how you rectify that solution, all right? One more, I'll do it. You know, you guys got a quiz coming up Friday. This is like the easy part of the quiz. It's supposed to be.
Teachers, for the rest of the day, you can just email your absentees to Miss Patty. I appreciate it.
Oh, that's a bummer. I missed my little break to eat. Okay. So the zeros of this function, zeros are also known as our x-intercepts. And you got one here, here, and here. So our x-intercepts are at -2, +1, and then 3. You don't have to write those out as ordered pairs. The average rate of change from x equals 0 to x equals 3. So here is where x is 0, and here is where x is 3. And I'm just going to go ahead and draw a line in here so I can go back to that 7th grade mentality of slope being rise over run. I fell 6, and I ran 3. And average rate of change, just a fancy way of saying slope abbreviated M. And -6/3 is -2. And then finally the y-intercept. And it's almost going to be comical and sad at the same time to see how many kids miss a y-intercept by asking. But the y-intercept is legit where you cross the y-axis, which is right there, right? And the ordered pair there is 0, 6. And there you go, kids. That's half your homework. You don't have to say thank you. You probably should. Hope you enjoyed.